Hello and welcome to Mathematics with Simon. Today we're going to look at indices in A-level mathematics. So what do we mean by indices? Well, for example, x squared equals x times x, and there the index is 2. Or x cubed equals x times x times x, and here the index is 3. Or x to the power n equals x times x times x times x n times. We put the dots in there to say there's a bunch of terms in the middle there, but we don't know how many. X to the n is x times itself n times. So they're examples of indices. When we multiply two terms together, we add the indices. So x to the a times x to the b equals x to the a plus b. Here's an example. So 3 to the power 4 times 3 to the power 5 equals 3 to the power 9. When we divide terms, we subtract the indices. So x to the a divided by x to the b equals x to the a minus b. When we raise to the power, we multiply indices. So x to the a to the power b equals x to the power ab. And then powers distribute over products. So x times y to the power a equals x to the a times y to the a. Any non-zero number raised to the power of 0 is equal to 1. So n to the 0 equals 1 as long as n is not equal to 0. If n is equal to 0, then you can't really calculate it. It's a bit like 0 divided by 0. It doesn't really have a value. Fractional powers represent roots. So n to the power half is the square root of n to the power 1/3 is the cube root of n, and n to the power 1 over a is the eighth root of n. It's the number you need to times by itself a times to give you n. And then we can look at fractional powers in more detail, more complex fractional powers. So n to the a over b equals n to the power a, and then take the bth root. For example, 8 to the power 2/3 equals the cube root of 8 squared. So 8 squared is 64, 8 times 8 is 64, and then the cube root is 4. So if you multiply 4 by 4 by 4, you get 64. 4 times 4 is 16, times 4 is 64. So 8 to the 2/3 is 4. Negative powers represent reciprocals. So n to the minus 1 equals 1 over n to the minus 2 is 1 over n squared. For example, 3 to the minus 2 is 1 over 3 squared, which is 1 over 9. Okay, so our last video was about proof. So how do we prove all of these facts? Okay, well, let's start off with 3 to the 2 times 3 to the 4 equals 3 to the 2 plus 4 equals 3 to the 6. Let's look at that in the general case. So if we've got x to the power a times x to the power b, the first term is x times itself a times x times x times x times x a times. The second term is x times itself b times x times x times x times x b times. So put those together, you've got x times itself a plus b times x times x times x a plus b times, which is just x to the power a plus b. So we've shown that x to the a times x to the b is x to the power a plus b, which is great. And then in these later proofs, we will use this important fact time and time again. But I just want to say before we go ahead, we've only proved this for positive whole number a and b. We haven't proved it for negative numbers or fractional numbers, and we actually won't do in this video. This is important to recognize because if you're going to carry out a proof, you have to do it for all cases. And I'm sure the enthusiastic student will work out ways to prove it for negative and fractional. It's not actually needed for A-level, but it's just worth pointing out that strictly we're only proving this for whole numbers at the moment. You don't strictly need the proofs for A-level, but it's nice to have the proofs so you understand why these things are true. X to the naught times x to the a equals x to the naught plus a, as using the rule on the previous page, which is just x to the a because naught plus a is a. So if we divide both sides by x to the a, that tells us that x to the naught is x to the a over x to the a, which is just 1. As long as we can divide by x to the a, So that relies on x to the a not being 0, which is why we need x not to be 0. So this only works if x is non-zero, as we said before. X to the minus a times x to the a equals x to the minus a plus a, which is just x to the 0, which is 1. So if then we divide both sides by x to the a, we get x to the minus a equals 1 over x to the a, which is what we were trying to prove. Negative powers are the same as reciprocals. Again, we've only proved it for whole numbers, not for fractions. It is true for fractions. Okay, we're now going to prove that x to the half is the square root of x. So x to the half times x to the half is x to the power half plus half, which is x to the 1. And x to the 1 equals x, because x to the 1 is x times itself one time, which is just x. So we've shown that x to the half is the number you times by itself to get x. Therefore, x to the half is the square root of x. X to the 1 over n times x to the 1 over n times dot 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 x to the 1 over n is x to the 1 over n plus 1 over n plus 1 over n times, which is just x to the 1. So that shows that x to the 1 over n is the number you have to times by itself n times to give you x. Therefore, it's the nth root of x. And finally, we're going to show that powers distribute over products. So x times y to the a is just x times y times x times y times x times y times dot 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 x times y. If we rearrange the order of the terms, which we can do with multiplication, we get x times itself a times y times itself a times, which is just x to the a times y to the a. So we've shown that x times y to the a is equal to x to the a times y to the a. I hope you like this video. If you do, please hit the like button. You're very welcome to subscribe and hit the notification bell. We're going to put the whole of A-level maths up here. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.